For this skill, we were first asked to find two cities, one in the southern and western hemispheres, which I chose to be Rio, and one in the northern and eastern hemispheres, which I chose to be Shanghai. So to do this, we first identified that the equinox for each place would be the same. So that starting point on the sinusoidal function, which we will use to model how daylight hours change for each location throughout the year, how that begins. So the starting point for each sine graph would be at 12, which is the equal amount of hours of daylight hours to nighttime hours, because 24 divided by 2 is 12. So that starting point has to be 12, and that gives me this plus 12 right here, because normally a sine graph starts at 0 and 0, but now we have to make it start at 0 and 12, and then 0 and 12 staying. So to do, next I had to do some research and find out how long a summer solstice, daylight hours were for each location. The summer solstice is the longest day of the year, meaning most daylight hours. So I just did this by a quick Google search and found that in Rio, it's about 14 hours, which is a 2-hour difference from the equinox, which makes sense because Rio is very close to the equator, meaning there would be very little, difference between solstice and equinox because it's so close to that center line of the earth, which is the equator. And then I found that for Shanghai, it is about 16 hours, which makes sense because Shanghai is obviously in the north hemisphere, which makes it farther away from the equator than Rio, so it has to be a bigger difference. So I know that because it deviates 4 from the equinox, so 12 plus 4 is 16, and this one would be 2 because 12 plus 2 is 14. I know my amplitudes for each. So 4 and 2, this is negative, but I'll talk about that later. So for 4, I know that's how far up it goes and how far down it goes, because the amplitude determines the maximums and minimums of the sine graph. So then I have my amplitude, and the last thing I need is my period. So in this case, we know that period for a sine graph is 2 pi over b, b being that transformation right there that's kind of scribbled in. So, and because I know that there are 12 months in a year, and that I'm using a year to be my gauge from equinox to equinox for right here, that's my period, I have to make sure that this 2 pi over b is equal to 12. So by just doing simple algebra and solving, I find that my period or b value is pi over 6. So I put that in there, and then I get my graph for Shanghai. And yes, so, and now, okay, we're going to talk about Rio. And the reason Rio has a negative amplitude of 2 is because Shanghai is in the north and Rio is in the south, their seasons are inverse of each other. So when it's summer in Shanghai, it's actually winter, or fall, I believe it's winter in Rio, because it changes based on how the earth is tilted. So that's why this has to be negative, and so it has to be opposite. So starting at the same day, there's a time difference. That's why these are different dates, but it's still the same basic period of time. So starting on the same day, it actually goes down to its equinox range, which is 10 hours right here, and then back up to an equinox, and then back up in December, which is where this one hits its lowest. That's where this is the highest, and that's its summer equinox, and then back down to the equinox where they're both equal.